Good afternoon. I am tasked to give the general equation for d cubed minus 6d squared plus 11d minus 6 all at times y plus f of x. So recall this equation for this equation y prime plus the dy, y prime plus d squared y, and y prime plus d cubed y. Now we need to know this in order to solve this equation, because as we distribute y, we get d cubed y minus 6 d squared y plus 11 dy minus 6y equals f of x. So remember, our d cubed y is just y prime minus our d squared y equals 6y prime plus 11 y prime minus 6y equals f of x. And now we have a standard solution, or an easier solution to understand, and that will lead us in solving its general solution. So remember, m is equal to e to the mx, and y prime is equal to m e to the mx, y prime plus m squared e to the mx, and y prime plus m cubed e to the mx. And by substituting this one to this equation, we'll arrive this thing: m cubed minus 6m squared plus 11m minus 6 equals f of x. Now, what we need to do is find the value of m. So, to find its value, using our math 17, we're gonna get m minus 1, m minus 2, m minus 3. And since we need to find first the complementary equation, or the homogeneous part, so we need to equate it into 0. Therefore, our y is equal to m plus 1, m plus 2, and m is equal to 3. And with this, we can now use the case 1 of the which is a real roots. And we have this yc. Yc is equal to c1 e to the x plus c2 e to the 2x plus c3 e to the dx, which is our complementary equation. And now to find the particular equation, let our y1 be e to the x, y2 e to the 2x, and y3 equals e to the 3x. And first, to make it easier, we get the Guiang equation. So w is equal to our y1 e to the x, y1 prime, which is still e to the x, and our y1 prime still e to the x. Next is our y2. So following the same pattern, we get e to the x, 2e to the x, and 4e to the, it's 2x, 2x. And the last one, e to the 3x, 3e to the 3x, and 9e to the 3x. Solving this matrix will give us 2e to the 6x. Now that we have w, or the Guiang, we can now easily solve u1, u2, and u3 for the particular equation, since our y3 is equal to u1 y1 plus u2 y2 plus u3 y3. Remember, our u1 prime is equal to integral of w1 over w. And since we know w is equal to 2e to the negative x, and now remember that our value on the right hand side is just f of x, a function of x. So we let that to be substituted in the Guiang equation for w1. So we have 0, 0, f of x, and we copy this term, e to the 2x, 4e to the 2x, 2 e to the 2x, 4e to the 2x, e to the 3x, 3e to the 3x, and 9e to the 3x. And solving this matrix will give us e to the 5x f of x. Same thing with you too. So we have to integrate it. So since you have w1 here, e to the 5x, and we're going to divide it with our radical, which is 2e to the 6x, and we get the value of integral of f of x over 2e to the x. Now for our u2, which is w2 over w, and having 2e to the 6x, and we get another matrix for the u2. So e to the x, e to the x, 0, 0, f of x, e to the 3x, 3e to the 3x, 9e to the 3x. And we'll have integral 2e to the 6x and negative 2e to the 4x f of x, and that will make negative f of x integral over e to the 2x. Then for our u3, because integral of w3 over w, and we follow the same pattern that will end up with e to the 3x f of x over 2e to the 6x, and that will give us integral of f of x over 2e to the 3x. Now we have the u1, u2, and u3. We can now write the y3 of the particular equation, which is our u1 integral of f of x over 2e to the x times our y1, which is e to the x plus integral of f of x, so it's minus, over u2, which is e to the 2x times we should be outside the integral to avoid confusion, so e to the x here, we will write e to the 2x plus integral of f of x over 2e to the x. And